All right, so we are back again. This time around, we are still under the solution of a differential equation, but it is not the first order. Here, we are looking for the second order, that is the higher derivative. So we may have something like this. All right, now let's talk about the equation we have on the board. So if you check the equation, we are saying that this is a higher derivative. That we mean that a derivative of equation of which its order is more than one. So if you check we have prime prime, which means we have the second order derivative. Now, if you want to talk about the order of a differential equation, you need to check the differential equation, the highest derivative we have in the differential equation. So here, if you check, the highest derivative we have over here is 2. That means the order of this differential equation is 2, which means we are talking about the second order. So we are saying that if you have something like this, of which the coefficient of the unknown variables are constant. So here we assume that A, B, C are constant. And if they are constant, and you can see that here 2 is equal to 0, then it means that we have the homogeneous differential equation. Can you see that? So we have the second order homogeneous differential equation. So if we have something like that, always we will assume that there is a solution for that, and that solution is always in this form. Y is equal to e raised power mx. So if we have a differential equation like this, we always assume that this is the solution for the differential equation. And you know that if this is the solution for the differential equation, it satisfies the equation, and that is really true. So here, if this one satisfies this, then it means that we'll make sure that this one will take the form of this, right? So you can see that I have y here, so I will substitute this one here. I have y prime here, so I will differentiate this one. The answer I will get, I will substitute it here. I have y prime prime. I will differentiate this one 2 times and substitute it there. After that, then I will see how I can solve the solution. Let's see what we have. So I will differentiate this one for the first time. I will get, now if we are differentiating exponential equation, you will get the same thing, exponential function. So you will get the same thing times the differential of the power. So if you differentiate the power, you will get what? We will get m times length of the base. This is the base and this is the power. So length of the base, that is length E. So if you find this very well, it means we will get what? Length E is 1. So we will get m e raised power mx. Let's differentiate it again. If we differentiate it again, we will get, so the same thing. We will assume that this is constant. Then we will maintain mx. We will multiply it by the differential of the power, which is m. Then we will find the length of the base, which is the same as 1. So here we will get m squared e raised power mx. Now let's do the substitution. So we will substitute all of them into the differential equation. Now if we do that, we will get a m squared e raised power mx, right? Then here we will get plus b m e raised power mx, then plus c e raised power mx, and is equal to 0. So you can see that we have e raised power ms, e raised power ms, e raised power ms. We can factorize that one out. So if we do that, we will get e raised power mx, bracket open. Here is am squared plus bm plus c, and is equal to 0. So if you have two things multiplying, or let's say if you have two functions multiplying, either one of them is 0 or both of them is 0. Now, if you check this, here we are saying that this is not equal to 0. So if this one is not equal to 0, automatically what we have here is equal to 0. So that means we'll get am squared plus bm plus c, and is equal to 0. What we have over here is called characteristic equation. So for you to find the solution for this, you need to solve this, and you can see that this is quadratic equation. So you use either the quadratic formula or any method you can use to get the answer. When you get the answer, then you substitute all of them over here. So we may face a condition where the roots are distinct real roots. So if they are distinct real roots, we have the solution for that. If they are repeated roots, we have the solution for that. If they are distinct but complex roots, that one we have a solution for that. So we are coming to look at how to what get the solution if the root first, if the root is raw and distinct root. So we will look for that one. So let's look at. So we are saying that if the root is raw and distinct, then it means that we will get b squared minus 4ac and it is greater than 0. So if we have something like that, then it means the root, that is, the solution for this will be y is equal to c1 e raised power m1x plus c2 e raised power m2x. This is where our m1 is not equal to m2. All of them are what? Are different, meaning we have the distinct root. So if we have something like that, this is the solution. Again, if we have the solution of which they are repeating, then the solution will be this. Y is equal to c1 e raised power mx plus c2 x e raised power mx. So this is the solution if we have a repeated root. And that one, if it is repeated root, we assume that it is what? Equal root. So this is what we are talking about. And again, if we have the root of which it is complex, they are distinct but complex. That means, so here, it means that m1 is equal to m2. So if when m1 is 0, m2 is 0, then it means that we will use this formula. Then lastly, if we get distinct root, but it is in complex form, then the solution will be c1 cos. Now, we will get e raised power alpha x bracket c1 cos beta x plus c2 sine of beta x. So here we are saying that you will get the root in this form. M is equal to alpha plus or minus I beta. So if you get something like this, the alpha is the one over here and the beta is this. So if you get it like that, this is the solution we will get. All right, in our next video, we will solve example and you will know how to use them to get the solution. Thank you for watching and make sure you subscribe to our channel.